Our final topic in the arithmetic power hour, and it's a big topic, is exponents. Again, with exponents, some memorizing is going to really help you. There are certain powers that keep showing up on the exam, and if you know them off the top of your head, for example, if you know that 2 to the 7th is 128, or that 3 to the 4th is 81, it'll really help you save time and maybe recognize patterns that other students don't see. The powers and their corresponding roots are another big part of my set of flashcards, if you'd be interested in looking at that. Memorizing these numbers is pretty intensive, and I really only recommend it for students who are fairly advanced or have plenty of time, and if improvement really means a lot to you and it's worth the trouble, then you can take a look at those flashcards. Anyway, moving on, the next thing we need to talk about is powers of various kinds of numbers. The GRE really likes to test us on how numbers behave. How do numbers behave when we multiply or divide them? We just talked about that issue. How do numbers behave when we take powers of them? That's the next issue. In particular, we're going to look at powers of fractions, powers of small numbers, and powers of negative numbers. So let's blow up the board and get started here with fractions. So the rule for taking a fraction to a power is to distribute the exponent. This is an example of a true distributive rule. There are some true distributive rules and some false ones. Most students' instinct always tells them that they're true, so the teacher's job is really to make sure that they don't do the false distributive rules. But this one is true, which means that your instinct is probably correct. So for example, to raise the fraction 2/5 to the third power, is it okay to just distribute this cube and go 2 cubed over 5 cubed? Your instinct would probably tell you yes, and you're right. It is correct. 2 to the third power is 8, and 5 to the third power is 125. And by the way, again, a note about memorizing these things, the GRE calculator does not have an exponents button. It doesn't even have a squaring button. And that's another reason that if you know these things by heart, it just saves you a lot of time and trouble. So you tell me, or you tell yourself, what is 1/9 squared? That one should be pretty easy for you. 1 over 81. So algebraically, the rule would be written like this. M over n to the power of p equals m to the p over n to the p. That p, the power, gets distributed and applied to both the numerator and the denominator. Moving on to the topic of small numbers. Here the rule is that a small number to a power is smaller. And I guess I should clarify again that this power has to be large for this rule to be true. A small number to a large power is smaller than what we started with. For example, we just learned how to take fractions to a power. What is 1/2 squared? You square each one of those numbers, you get 1/4. 1/4 is smaller than a half. With large numbers, the large numbers to a power keep getting larger, right? 2 squared is 4, 2 cubed is 8. Those numbers are all getting bigger and bigger. But when we're starting with a small base, its powers keep getting smaller and smaller. 1/2 cubed is 1/8. That's even smaller than a fourth. So if I kept raising a half to powers 1/2 to the fourth, 1/2 to the fifth, 1/2 to the sixth, those powers would keep getting smaller and smaller and smaller and shrinking towards 0. 0.3 is a small number, so we would expect that if you square it, you'll get a number smaller than 0.3. And this is easy to execute on your calculator, and you will find that 0.09, which is less than 0.3. So whether it's written as a fraction or a decimal or even an irrational number, here's the rule. If x is a small number between 0 and 1, then x to a power will be less than itself. And x, as those powers keep growing, as the exponent keeps growing, the powers keep getting smaller. Let's take a look at powers of negative numbers. We're going to start with a base of -2. I've put the -2 in parentheses to indicate that all of that is the base. The base is not just 2, but -2. So as -2 gets squared, that really means -2 times -2. And I think we remember that negative times negative is positive. And therefore that result would be +4. What about -2 cubed? -2 to the third power. That really means -2 times -2 times -2. So 2 of those negatives will cancel out to give us a positive, but there's still a negative left. And the result would be -8. What about -2 to the fourth power? This one has 2 pairs of negatives. They both cancel each other out, giving us a positive result. Fifth power, well, these 2 pairs cancel each other out, but there's still a negative left over, and that leaves us with the negative result. Now, are we beginning to see the pattern here? If we have an even exponent, then we get a positive result. However, when we see an odd exponent, then we get a negative result. Sometimes I write the memory device, nope. Negative, odd, positive, even. It just summarizes this rule. So, when we know that rule, we should be able to work out crazy things like which one is bigger? -2 to the 380th power or -2 to the 381st power? I don't know how big those numbers are. There's some astronomical numbers. However, I do know that this one has an even exponent, so this number is positive, and this one has a an odd exponent, so its answer must be negative, and therefore A must be larger. Do you think that you could execute this one? -1 to the power of 364,205. Well, really the same rule. This is an odd exponent, therefore we would expect the result to be negative, and all powers of 1 are just 1. We have to be careful when we do these problems about the order of operations. I've rewritten the powers of 2 on the board, but I'm putting the parentheses in a different place now. So now I'm putting the parentheses not around the -2, but around the 2 squared. So that basically indicates to us that we're going to be doing things, we're going to be operating in slightly different order. So I think it should be clear to you that this one is no longer +4, it's negative now. The way we think about this is, because we see the parentheses here, it indicates that the first thing we do is we take the exponent 4, and then we take its opposite. Okay, this one would also be -8. I think you should agree that all of them will be negative now. By the way, when you see a negative sign in front of a number, you can interpret it in 2 different ways. If you see like a negative in front of 7, you can think about this as meaning -1 times 7, or you can think about it as meaning 0 minus 7. So that makes it a true and proper operation. Okay, now keeping this hint in mind, what I want to do next is get rid of the parentheses altogether. So what would happen if I took these parentheses away? Now is the answer going to be positive or negative? So if we just see something written as like -2 cubed with no parentheses written there, is that supposed to be interpreted as -2? Well, I guess in the odd case it doesn't matter, does it? Because this is, we saw that this was negative both times. So if the exponent is odd, then we know the answer is always going to be negative. Okay, so those are easy. The tricky issue is over here when the exponent is even. So when we see this, should we interpret it more like that which is 4 or that which is -4? I'll give you a hint. 99% of students get this problem wrong. And you know what? The ETS knows that, and they put it on the test deliberately. So your instinct is probably wrong. You're probably saying, well, of course, everybody knows that that's positive because a negative number squared is positive. If that's what you're saying, your instinct is wrong because you're interpreting it incorrectly. You're using the wrong order of operations. The answer will always be negative. And we can use this principle to prove it. So basically, remember when you see a negative sign in front of a number, when you see a negative sign in front of 2 squared, you can interpret that either as -1 times 2 squared or 0 minus 2 squared. So that turns it into a true arithmetic problem where you're operating with 2 numbers together. So let's take a look at this one. We see a multiply, and an exponent. Which one gets executed first? The exponent. So that tells us it's the same as -1 times 4, which is -4. Let's interpret it this way. When we see -2 squared, we can also interpret that as 0 minus 2 squared. Minus exponent. Which one comes first? The exponent. 0 minus 4 is -4. It's mathematically consistent. It's proven. Students really like to argue about this one. But the reason that you might be getting this wrong is because when you see this, you are assuming this. And that's the wrong assumption. Okay? I didn't write that. I didn't put the parentheses there. You did. You put them in your own mind. They don't belong there. So think about your correct order of operations, and remember that a negative sign in front of any power is always negative, isn't it? If there are no parentheses, the result will always be negative.